Hello YouTube, just another update on Rover here. This is the back end of the gearbox, motor, and wheel assembly for Rover. So here's the wheel, and you can see the motor there. You'll notice the motor and wheel will turn at a different rate because there's a gearbox in there as well. But this is an update to show an assembly step on Rover. At the back end of the motor here, right there, Rover has this magnetic sensor here. This sensor's on my GitHub, and it's a sensor that plugs into the motor controller. It's got this sensor here, which is a magnetic rotary position sensor. So the way this works is there's a magnet that I'm going to show you in this video how to super glue onto the back of the motor shaft there, and then this screws over the back of it, and the motor is radially magnetized, or sorry, the magnet is radially magnetized. So a normal magnet that's a cylinder is going to have north and south on the top and bottoms of the cylinder, but these ones are magnetized the other way, sideways. So that what happens is when you glue that magnet down here and the wheel and the motor rotate, the magnetic field rotates as well. And then this sensor has a couple of magnetic pickups at some angle from each other. And when the magnetic field rotates, this can figure that out. And it sends an SPI signal back to the motor controller at about 9,000 counts per revolution, or probably 8,000 counts per revolution, to give the position of the motor to the motor controller, and that helps the motor controller have efficient, high torque control. This is different from a hobby motor, or a hobby motor controller that's not going to have this kind of control, and it's one of the reasons that I use expensive motor controllers, even though cheaper ones would spin the motor, but the controllers that can take this kind of an encoder for feedback provide much more precise control. So a big, heavy robot like Rover can still move with precision. So I'm just going to show how to super glue the magnet on, and I'm hoping that this will go well. It's a little bit of a finicky task, but so far I've succeeded every time. So I've got some super glue. This is an extra time super glue, and I tend to like the gel based ones. I don't want to glue the motor to the housing, and I like the gel ones because they'll stay in place, but I don't think that's what this is. Anyway, I'm gonna put a little drop of super glue right in the middle, maybe a big drop actually, and then I'm gonna pull my magnet, which I've got over here, and they love to flip over because they're radially magnetized. So then it becomes a sort of frightening little dance. Wonderful, okay. So I've gotten it flat, which is the tricky part. Keeping it in the middle now. How's that look? There we go. Now you can see it's been glued in, and then what's I think important is to rotate this a little bit so that while it's drying, if any part of the motor is stuck to your plastic, it won't dry that way. And it's probably not perfectly centered, but so far on every, let's see, I've done 4 motors on Rover V1 and 2 motors on Skittles, and I never had to reposition the magnet. So you can see that I'm just gluing this on by hand, and so far that's all worked very well for me. So it doesn't have to be perfectly centered. And you just rotate this a little bit. I'm really pleased that this went well. That is actually all you need to do to glue the magnet on. And then once that's dry, I'll screw this over the top of it, and I'll have to do that for 3 more assemblies, and then I'll have the magnets glued on for Rover version 2. I'm happy that I've got one complete now, because I can hook up the Raspberry Pi to it, hook up a controller to that, and bring up all of Rover's control software using just a single motor and make sure that everything really works as I would expect it to. And that's really easy and small. And then once that works, I'll put magnets on the other 3 assemblies for Rover V2 and put it together. Also, this is the magnet that I used. It's from amazingmagnets.com. They're out of California, so I really like them. But if you have your own magnetic supplier you'd like to use, you can still go to this website and then look up this part number, the D125A2-DM. And it's important that it's a diametrically or radially magnetized magnet rather than an axially magnetized magnet. But if you look this one up, you'll find exactly the specs for what I was using. And you can search your own local supplier for the same, or go to amazingmagnets.com if you can order from California. I've been very happy with them as a magnet supplier. Yep, so anyway, that is the procedure for gluing the magnet onto the motor for Rover. And if you wanted to build a Skittles, then it would be very much the same. This hooks up to the VESC motor controller, VESC motor controller. And this is my own sensor board that I designed that's going to go on the top of that once that's dry, just with some of these little screws. I designed this in KiCad, and the files for this are open source and on my GitHub. My GitHub is TL Alexander. And unfortunately, these motor control chips, these encoder chips, which are the only ones available, the only ones that are by default compatible with the VESC, the chip itself is out of stock, so you end up having to buy a board, pull the chip off of the other board, and put it on here. I'm not totally sure that I can recommend these, but if you want to get started ASAP and use the VESC, then these are really great. Yep. All right, I think that should be plenty. So thanks for watching, and if you want more information on Rover, please visit Reboot.love. Thanks.